Hi, welcome to Math Minute. My name is Adam, and today we're going to be talking about linear functions. So, first we're going to talk about this formula. And this formula is what we're knowing as a linear function formula, or the linear equation. So what we have is we have our output, which is what we talked about last time. That was y. That's what we get out of this. We're putting something in, and we're going to get it in. We're going to get the output out. So we also have the rate of change. This is going to be something that actually really defines what the linear function is and how they're different from the other linear functions. So we also know our input from last time. X, we plug it in, we get something out. Also the initial value, which now, if we look at this graph, we can talk about what these pieces are. I've drawn here B, and this is known as our initial value. If we're starting with x equals 0, that's the initial point, then what is our y value? B. So we can say that the initial value is B. Now this m, I'm sure we can assume that it's the rate of change, but why? What does that mean? Well, what we're trying to find out is how much does y change as we move down x? So how much does y increase or decrease as we move along x? So that's why we do rise over run. So that's what the rate of change is, m. So now we've kind of built this formula that we need. And what we're going to see is a linear function. Y equals mx plus b. Y equals m times x plus b, which is, in long term, output equals the rate of change times the input plus the initial value. And we really don't want to say that every time, and that's why variables are useful in math. So as I stated here, m equals the rate of change, b equals the initial value, or the y-intercept. So let's talk about that specific example that we did last time. If we're driving for 60 miles an hour, which would be our rate, and that's m, rate of change is the speed, so 60. Now, where did we start? That's kind of another question. What's our initial value? Well, do we have any distance away from our home if we start at our home? No. So b in this case is just going to be 0. We're starting at home. We don't have any distance yet. So x is that variable, right? But we're going to talk about a specific case, let's say 2 hours. So time is 2. So 60 times 2 plus 0. 60 times 2, 120. So like we said last time, we will drive 120 miles. So now I'm going to give a specific example. I'm going to draw a case of a linear function. So what I'm going to give is a set of x and y values. So let's do this in table form. This is kind of similar to ordered pair, but a little different. So we have x and y values. So if we have 0, 1, 2, and 3 in our x values, and they correspond with 1, 2, 3, and 4, respectively. So let's just graph this. Let's see if we can get the components from graphing. So if we have 1, 2, 3, so 0 is our x value, 1, 2, 3. These are the x values. And we have 1 through 4. So 1, 2, 3, 4. Let's number them off on our y-axis. 1, 2, 3, and 4. So now we're just going to plug in our ordered pairs. 0, 1. X value is 0, y value is 1. 1 and 2. 1, 2. 2 and 3. 2, 3, and 3 and 4. 3, 4. So as you see, we have a straight line right through there. Okay? So what we talked about before is where does it cross the y-axis? What's the initial value? Well, we can see pretty obviously that when x equals 0, y equals 1. So b in this case is 1. Okay? Let's talk about the slope, or the rate of change, m. So what we have is we're going to figure out how far up the the y-axis we go for each x value. So let's see here. We take rise over run. We can do that in any case. So we can do this from here to here. We can do this from here to here. But every time it's going to be the same thing. In this case, it was 1, 2 over 1, 2, which is 1. 1, 2 over 1, 2, which is 1 again. And even in these little cases, 1 over 1. So our m is going to be 1. These are the only two things we need to form our linear function. So from this, we can get our equation. Y equals mx plus b. So we're going to plug this in. Y equals 1 times x plus 1. Or we can write that as y equals x plus 1. This is a really easy case of a linear function. And we have our y and our x as our variables. We're going to put in an x value and get out a y value. So in this case, let's just show how it works. We plug in 1. Let me use these. We plug in 1, we get out 2. Our function was y equals x plus 1. So we can verify all these points. 0 plus 1 equals 1. 1 plus 1 equals 2. 2 plus 1 equals 3. 3 plus 1 equals 4. So this is how linear functions work. They're very constant. As you can see, they have a constant rate, which is a little different from other things we're going to talk about. But this is just a linear function, how it acts, and how we can get the formula. So thanks for watching. We'll see you next time.